In 5.2, we will be introduced to solving quadratic equations. So at first, we're going to solve quadratic equations by using square roots. And this is where our radical review will come in very, very handy, your radical review from Algebra 1. And if you are a little bit shaky on simplifying radicals, you may want to check out some of the early videos of Chapter 5 that are titled Radical Review. So let's start with this one here. We have 4x squared plus 13 equals 253. Well, what we want to do here is we want to isolate that x squared. Our goal is to isolate this x squared right here. So to do that, the first thing we can do is we can subtract 13. So I'm left with 4x squared equals 240. Now to get that x squared alone, we got to divide by 4. So we get x squared equals 60. Now what I can do is I can take the square root of x squared to get it to be x, but if I do that to one side, I got to do the other. So I get x equals the square root of 60. Now one thing to note, remember when we square something, if we square 3 we get 9, if we square negative 3 we get 9. Either way we get positive 9. So we have to take into account that both signs will work. Both positive or negative square root 60 squared is going to give me 60. So I have to have that plus or minus when I'm taking the square root of both sides. Now this isn't going to work for my final answer. I do need to simplify the square root of 60. So right now I have x equals plus or minus the square root of 60. And what I can do here is I like to look for perfect squares. Well, 60 divided by 4 would give me 15. I know that I can't simplify 15 at all, but I know that the square root of 4 is 2, and I would be left with the square root of 15 inside there. So my answer is going to be x equals plus or minus 2 root 15. And if you weren't sure how to do this part right here, if you weren't sure how to do this, check out those early videos in Chapter 5 titled Radical Review. That will really, really help you out. Because if you don't know how to do this right here, you're going to have a bad time. Let's also get an approximate answer for this one here. So this is our exact answer. There's no decimals. When we have decimals, although a lot of us think like, oh, decimals are super exact. Well, no, we round decimals, so that's considered an approximate answer. So if we plug in 2 times the square root of 15 into our calculator, we're going to be left with x equals plus or minus 7 point, and why don't we go with just the nearest hundredth? So it'll be 7, and then it's 4, 5, so we're going to have 7.75. Because our decimal looks like this, 7.74596. So this 5 right here rounds that 4 up to a 5. So we get plus or minus 7.75 approximately. And actually we want to use these squiggly equals right here. Let's try another example. Once again, we want to isolate the squared part. This time the squared part is actually x minus 2 quantity squared. Okay, so what I'm going to do first here is I'm going to divide by 9. I can't distribute that 9 in there. There's an exponent. You can't distribute when there's an exponent there. I'm left with x minus 2 in parentheses squared equals, well, 121 divided by 9. That won't simplify out nicely, so I'm just going to leave it as 121 over 9. And what you'll notice that happens is when I square root both sides to get rid of that squared part right up here, I want to get rid of the squared, so to undo that I do the square root. I have x minus 2 equals plus or minus the square root of 121 over 9. Well, the square root of 121 is 11. Square root of 9 is 3. Oops, not 9, 3. So, to then solve for x, I'm going to add 2 to both sides. So add 2. And I'm left with x equals 2, and then plus or minus 11 over 3. And we can just leave it like that. We don't need to have 2 different ones. This plus or minus really gives us 2 different answers. It's 2 plus 11 over 3 and 2 minus 11 over 3. So there are 2 answers here. Once again, let's get a decimal answer as well, because sometimes we'll be asked for approximate, sometimes we'll be asked for exact. Again, this is our exact answer. There's no decimals here. Decimals are not usually exact. So to get our decimal equivalent, our approximate decimal answer, we have to do 2 things. One will have to be x equals, in our calculator we'll plug in 2 plus 11 over 3, and that gives us 5.6 repeating, so we'll say 5.67. And then we'll also have to do 2 minus 11 over 3, which gives us negative 1.6 repeating, so 1.67. and these would be our two decimal approximations. So once again, you see there's two answers here. There's the two answers here. Here's our exact. These are our approximate. Last one that we'll do here. Once again, I need to isolate the squared part. This squared part here is once again a quantity x plus 1. So I'm going to divide by 7. And I'm left with x plus 1 squared equals 161 over 7. Well, 161 divided by 7 is 23. So I have x plus 1 squared equals 23. I'm going to square root both sides. Remember, we got to get rid of that squared. So to do that, we take the square root of both sides. So I'm left with x plus 1 equals plus or minus the square root of 23. Now, are there any perfect squares that I can take out of 23? Can it be? Is it divisible by 4? No. Is it divisible by 9? No. Is it divisible by 16? No. How about 25? No. Okay, well, there's nothing I can do. So lastly, what I'm going to do is I'm going to subtract 1 from both sides. I'm going to have x equals negative 1 plus or minus the square root of 23. So remember, it's like negative 1 plus the square root of 23 and negative 1 minus the square root of 23. I have two solutions here. Let's get our decimal approximation one more time here. So to do this one, remember, we have to plug in two separate things into our calculator. We have to do negative 1 plus the square root of 23, and we have to do negative 1 minus the square root of 23. So why don't you try that right now in your calculator. So for this one, we end up with approximately 3.79583. So let's round that now. Notice what we have with the 3.79583. Well, the 9 is going to be rounded up by that 5, so if we're going to the nearest hundredth, we actually have to go to 3.80 for this one, or 3.8. And then down here we have a similar situation. It's negative 5.795, so I'm really going to have negative 5.80.